All right, welcome back. We are in a new week, a new lesson. Let's dive right into lesson 9, solutions of inequalities. All right, our first activity today, I really like because there's not just one correct answer. There's lots of correct answers for this one. So let's take a look. It says a number line shows several points, each labeled with a letter. So if we notice, this number line doesn't have a whole lot of numbers labeled, but it does have 0 labeled right here, which happens to be point D. So we know where D lives. But none of these other ones have numbers labeled, but they do have letters labeled. So we can compare them that way. Let's fill in each blank with a letter so that the inequality statement is true. All right, here we go, part A. Blank is greater than blank. Do you see how there's so many different right answers for this one? What is greater than what? Well, we know that any of the positive numbers, because they're to the right of 0, are going to be greater than any of the negative numbers. So we could pick any of these to be our first blank and any of these to be our second blank. How about E is greater than B? E is greater than B. That makes sense. Okay. Now, did you have to put that answer down? No, there's lots of them. We'll talk about that more in a little bit. Let's go on to part B. This one says blank is less than blank. Okay, so it's the other way around. Something on the left-hand side would be less than something on the right-hand side, right? So what do we want to say here? Should we say that A is less than, I don't know. Does it even have to be a positive number? No. Could I do C? Is A less than C? Yep, that is a possibility for that one, okay? So, like I said, there's lots of different answers there, and in fact, that's what number 2 is all about, because Jada says that she found 3 different ways to complete the first question correctly. So just this first one, she found 3 different ways of doing it. Do you think that is possible? Well, I tend to think that maybe we can, because we have one way. E is greater than B. Could I also say that E is greater than C? Yes. Could I say that F is greater than B? Yes. Could I say that F is greater than A? Could I say that E is greater than A? I mean, I could keep going and keep going and keep going. There are so many of these because anything to the right is greater than, and I typoed there, is greater than anything to its left, right? Anything to the right is going to be greater than anything to its left. So there are lots of different answers for that one, okay? List a possible value for each letter on the number line based on its location. Okay, so right now, the only one we know is that D equals 0. That is the only one we know right now because it's the only one that's labeled. But there's lots of different ways of figuring out what possible values of these would be. Now, the first thing I would like to do is remember clear back several lessons ago when we folded along the 0 to see where things lined up. I'm kind of curious to see if any of these are opposites. So that's the first thing I'm going to look for. I'm going to take this paper and I'm going to fold it in half right on D and see if any of these line up. Now this is going to take a second and it has to be really carefully done. Make sure the paper is totally straight when you're folding this. Make sure it goes right through that point D, because that's our 0 center point. Let's see if I did it. That's pretty darn close here. I was a little bit off, so I'm going to refold that line a little bit. Okay, I think I did a pretty good job. We'll see how I did. Looks like I did pretty good. Okay, so I'm going to hold this paper up to the light and see if any of these line up. Now, when I do this, I know you can't see what I'm doing, but maybe you're doing this at the same time that I'm doing it so that you can see what I'm seeing. As I'm holding this up to the light, I am seeing something very interesting. I'm seeing that point E and point B are right on top of each other. Did anybody else notice that? I think that E and B were right on top of each other. So they're opposites of each other. Now the only thing we need to figure out is what possible values could they have? Well, nothing is exact. Like this isn't 1 and this isn't 2 because this is further away here than this is. So what I'm tempted to say is things like, if this is 2, maybe this is 5. Does that kind of make sense? Because halfway between 5 would be 2.5, and that would be right there. So I'm thinking maybe this is 2. I'm going to say C is -2, and that would make B -5. Well, if B is -5, then E would be +5. We just discovered those are opposites. Okay. Now, if that's true, what do we think the possible values of A and F might be? I'm going to take a look at my folded paper again, and I don't think they line up. Nope, they don't at all. Maybe you could even see that. F is right here, and A is clear over here. See how different those are? So they're not lined up at all, but if I compare those to B and E, it looks like, is that F might be right in the middle of A and E. So if this is 5 and it fell right in the middle of this, that's what I noticed when I flipped this over here. It looked like it fell right in the middle. So if that's 5, that might be -10 and that might be -15. And that kind of makes sense to me because those look about equidistant, don't they? So I'm going to just take a guess here and say that A is -15 and that F is a +10 because it fell here at -10, but that would be its opposite at +10. Now, is that going to be exactly right? Maybe not. Maybe I want to adjust it a little bit because I'm noticing if this is 5, does that look like another 5? It doesn't quite look like 5. So maybe I'll adjust and say maybe it's just 9 instead of 10. I'm going to make that adjustment. See, there's always adjustment that can be made to see if you can get it as close as possible. Now, are those the only possible answers? Absolutely not. I could have counted by any. I could have even said this was -5. Then maybe this would have been -12, right? Or anything in between, right? I could have even made these fractions. So there's no right or wrong to this. It's just make sure that if whatever you do pick, that everything kind of makes sense in relationships to each other. That's all that's important. And that's kind of the point of this one, okay? Very, very good on activity number 1. Moving on to activity number 2. This is all about amusement park rides. Have any of you been on an amusement park ride where you've seen a sign that says you have to be a certain height? I have. I remember when I was little at Lagoon, I sometimes couldn't go on rides because I was too short. Dang it. Maybe that's happened to you, but that's what this is all about. It says Priya finds these height requirements for some of the rides at an amusement park. The high bounce, you had to be between 55 and 72 inches tall. The climb-a-thon, you had to be under 60 inches tall. So if you were too tall, they wouldn't let you on. The Twiltle coaster, you had to be a minimum of 58 inches tall. So you had to be a certain height or else they wouldn't let you on. All right. Number 1 says, write an inequality for each of the 3 height requirements. Use H for the unknown height, then represent each height requirement on the number line. Okay, so the first thing we need to do is write some kind of an inequality. Okay, write an inequality. Something is less than or greater to something using H, right? H is going to be our height. Okay, so for the high bounce, our height has to be between 55 and 72 inches tall. That means I have to be taller than 55, but shorter than 72. So that might take 2 inequalities, right? H has to be taller or greater than 55 and H has to be less than or shorter than 72. Does that make sense to everybody? I had to be taller or greater than 55 inches, but I had to be less than or smaller than, shorter than 72 inches tall. All right, well, let's see if we can put that on our number line. The first thing we notice when we look at these number lines is right now, they are naked. Now, don't tell your mom I said that word, but yes, they are naked right now. We've talked about this in class. There's no numbers on them, and we need to fix that. So the first thing I'm going to notice is if I start at 0, can I count all the way up to 55 on this number line? No way. So I'm going to have to start, first of all, start closer to 55. And second of all, I don't even know if I can count by ones. I think we might have to count by twos. So I'm going to start at 50 because that's kind of close to 55. But I'm going to count by twos. See how we do here. 54, 56, 58, 60, 62, 64, 66, 68, 70, 72, 74, 76, 78, 80, 82. Now, that got kind of squishy, but I think we made it okay. I'm going to fix 54. It got a little ugly looking. But I think that works, okay? Now, where's 55 on this graph? Well, it's halfway between 54 and 56. Do we do an open circle or a closed circle? Well, it has to be greater than 55. So that means it's going to be an open circle at 55. And I'm going to make it nice and big, right on 55. So it's going to be greater than 55, which means my arrow is going to go to the right of 55. But I have to be super careful how far I go, because does it go all the way to the end? No, because I also have to be less than 72. So we better put that on here as well. Where's my 72? Here it is. I have to be less than 72. So once again, that's an open circle at 72. This time I have to be less than that. So I'm going to shade to the left of 72. And look, our two graphs run into each other. And that's exactly what I expected, because we knew we had to be between 55 and 72. So I knew that those would be our boundaries of our graph. So there's our graph. H is between 55 and 72 inches tall. Okay? Next one, the climathon. Our height needs to be under 60 inches tall. Okay. So I'm actually going to label this graph exactly the same as this one, because then things will match up and we'll be able to compare. So I'm going to go ahead and label this 50, 52, 54, 56, all the way up. You can be doing the same thing if you haven't already. Watch me so that I don't mess this up, right? Looks like I got to the same place. And while I'm at it, I'm going to go ahead and do this next one as well. Might as well make them all match. But I like that they left them blank for us so that we had to think about this one. I almost doubled up the 64s. This is now 66. Okay, I've got them all labeled up now. Let's look at the climathon. Again, our height has to be under 60 inches. Well, under, the key word there, means it has to be below or less than 60 inches. So let's find our 60 inches on here. There it is right there. Once again, we're not equal to 60 inches. We have to be under 60 inches. So this is going to be another open circle. And under 60 inches means we have to be less than that. So that's going to be our arrow to the left. Now that's our only boundary, right? It's 60 inches. So that's going to end in an arrow. Now I realize I'm not going to have a height under 0, right? Because that's impossible for humans to have a height under 0 inches. But for our graph here, that's good enough. We know that a height from 60 all the way down to 0 will be a good graph. Oh, we forgot to write our inequality. H is less than 60. Okay? Now we are ready for the Twilto coaster. The Twilto coaster says that we have to have 58 inches minimum. There's our key word there. We need to know what that means. That means at the lowest or at the least, we have to be 58 inches tall. So can we be taller than 58? Yes. Can we be shorter than 58? Nope, because that's our minimum. 58 is the shortest we can be. So if we're doing our inequality for this one, if the shortest we can be is 58, then our height has to be either greater than 58 or our height can equal 58 in this case, because the 58 is the minimum. I can be 58 or I have to be taller than that. Okay, so that's going to change our graph in one very important way. The fact that we know that our height can equal 58 is going to give us a solid circle. This time, because it's also equal to 58, that's when we do what's called a closed circle, okay? Now, if I have to be taller than 58 or greater than 58, my arrow is going to go to the right. So I'm going to make a nice thick arrow going all the way to the right, greater than 58 inches. And then I'm going to put a nice big arrow at the end to say that I could be as tall as a giant and still go on this ride, right? As long as I'm taller than 58 inches. There we go. So now we have all of our graphs done, all of our inequalities written. So we are done with number 1. Ready to move on to number 2. Let's slide up a little bit. Han's cousin is 55 inches tall. Han doesn't think she is tall enough to ride the high bounce, but Kieran believes that she is tall enough. Do you agree with Han or Kieran? Okay, so the cousin is 55 inches tall. Let's take a look at the high bounce. Let's find her height of 55 inches tall. Well, 55 inches tall is right here on that open circle, isn't it? That was our borderline. Was 55 inches tall a solution to that inequality? If I say H is 55 greater than 55? Darn, I think that open circle means no. I think she is not tall enough. So who would be correct if she's not tall enough? Han doesn't think she's tall enough, so I think I have to agree with Han. Han is right. She needs to be taller than 55 inches, right? She has to be taller than that, and she's exactly 55, so that is not good enough. Darn, so close, Han's cousin. All right, moving on to number 3 in this activity. I'm going to keep these other problems close by because I think we're going to need them here. Here we go, number 3. Priya can ride the climathon, but she cannot ride the high bounce or the twilto coaster. Which of any of the following could be Priya's height? Be prepared to explain your reasoning. All right, let's see. 59 inches. Let's find 59 on all of these. And here's a good reason why I chose to put them all the same numbers here so that I could really compare. Where's 59? Well, it's right here between 58 and 60. So I'm going to draw a line right down at 59 on all of those. You see how I did that? Just to show where they are and decide which one matches. It says that Priya can ride the climathon. Is that true if she's 59? Yep, that's true. She can ride the climathon, can't she? Because she is less than 60 inches, which is what that said. So that's true, but she cannot ride the high bounce or the twilto coaster. Uh-oh. Well, according to this, if she was 59 inches, she could ride the high bounce. And she could ride the twilto coaster. So 59 inches must not be her height. Let's try 53. Where's 53? Well, it's halfway between 52 and 54. So once again, I'm going to draw a line right down in between 52 and 54, and that's where 53 is. Could she possibly be 53 inches tall. Well, it says that she can ride the climathon. Is that a solution to the climathon? Yes. So yes, she can ride the climathon. Can she ride the high bounce? No, because that's not on my graph. Can she ride the tilt-a coaster? No. Look at that. That's a possibility. I think she can be 53 inches tall because this one was the yes we were wanting, but these were the no's that we were expecting. So good. Let's see about 56 inches tall. 56 inches tall would be right here on this line. So let's mark right on that line of 56. 56. Okay. So for 56 inches tall, can she ride the climathon? Yes. Can she ride the tilt-a coaster? No. So far, so good. Uh-oh, what happened up here, though? Can she ride the high bounce? Yep. But we found that Priya cannot ride the high bounce. See how it says she cannot ride the high bounce? So this one must not be her true height. She must not be 56 inches. So there we found it. Priya must be 53 inches tall because that is the one that obeys all the different rules. Okay? Jada is 56 inches tall. Which rides can she go on? Oh, we already marked 56. Can she go on the high bounce? Yep. Jada can go on the high bounce. Can she go on the climathon? Yep, I landed right on my arrow on the climathon. I put my dot in the wrong spot. Climb, how do you spell this one? Climb-a-thon. Kind of funny names for these. Can she go on the twirl-o coaster? No, that wasn't on the graph, so that's it. So just those two. She can go on the high bounce and the climathon. Kieran is the tallest of all of them. He is 60 inches tall. What rides can he go on? Well, let's take a look. Where is 60? 60 is right here, right above our 59 line. Can he go on the high bounce? Yes, that's on my line. So high bounce is a yes. Let's look at the climathon. If he is 60 inches tall, oh, that's an open circle at 60, so that's a no for the climathon. You have to be shorter than 60 there, so that's a no for the climathon. How about the twirl-o coaster? If he's 60 inches, here's my 60 inches. I should have gone ahead and drawn a line on those ones. 60 inches is right there. That would be a yes for the twirl-o coaster, so I'm going to write that down. Twirl-o coaster is a yes for Kieran. Okay. Good, good, good. Last one, number 6. I hope we can still see number 6 on our paper here. The inequalities h is less than 75 and h is greater than 64 represent the height restrictions in inches of another ride. Write 3 values that are solutions to both of these inequalities. Okay. So it has to be less than 75, but greater than 64. So what I'm thinking, and I'm just going to hand draw, it has to be greater than 64, right? But it has to be less than 75. Does that make sense? So if this was a number line, I would have an open circle at 75, an open circle at 64, and it would be everything in between. So can we think of some numbers in between 64 and 75? Yeah, I can think of a lot of them. H can be 66. H can be 69. H can be 72. H can be anything in there. So it says to write 3 values. Okay, I've done 3. Could you do more than that? Absolutely. Okay, but those are the 3 I'm going to pick because they lie bigger than 64 and less than 75. Okay, now the next part in this activity is the are you ready for more? And while I am going to still say that this is optional, this is a good one. I really like this one. What it asks you to do is to redraw all 3 of these graphs all on the same number line. When we put more than one graph all on the same line, it makes that comparison even easier to see. That's what it's asking you to do. And it's asking you to use 3 different colors. so that you can tell the difference between each one of them. And then it has a couple of questions about those. I really like this one. It's a really fun way to take a look at those same 3 graphs all on the same line. So I highly recommend, honor students, I want you to try that one, okay? The last activity in this lesson today is actually a game. For this game, you need the printout of the Black Line Master, okay? It's on canvas. You can print this out, and then you'll have to cut out all these cards. Notice they're all different sizes, so be careful when you're cutting. And then there are 2 stacks of cards here. One stack are just these numbers. Do you see these 8 numbers up here at the top? That's one stack, and you're going to stack those up, mix them up, stack them up face down for this game. And then all of these inequalities and graphs, cut those out, but then lay them out where people can see them, okay? That's how you set up this game. Now, the rest of the instructions for this game are on this, in your workbook, okay? Or if you printed out these pages, they're on the pages. So these are the rules of the game. It's best if you play it with a total of 4 players, but if you have to play it with 2, that's okay. If you have to play it with 3, that's okay. But get your family involved in this. This is a really fun way to practice basically matching numbers as solutions to inequalities and as solutions on the graph. It's a great game to play to practice those skills, okay? Now, if you're all alone and nobody is around, and you can't really play this as a game, then just try it as a matching game. See if you can figure out what numbers match which inequalities and match which graph. Just do it as a matching. But if you've got more than a couple of people that can play it with you, what a great way to have some fun with your brothers and sisters or cousins or whoever else is in your house with you. Okay? So that's activity number 3. And that is the last activity of our lesson. Don't forget to read through the summary, practice graphing and writing inequalities using the examples in this summary. And then, of course, once you're done with that, you are ready to do your practice problems. There is one vocabulary word today, solution to an inequality. What makes it a yes, right? What falls on the arrow is the solution to an inequality. If you need to look up that definition in your glossary, you're welcome to do so. We are now ready to do our practice problems in our workbook. So flip the page, flip over to those, and as always,
do your best because you deserve your best.
So the decision we made that was yes, 60 miles per hour was the limit, but it was still an okay speed. So I'm going to say yes, 60 miles per hour is the limit, but is still a solution. It is still okay, right? Even if you won't get a ticket if you're going 60 miles an hour, if the speed limit is 60 miles per hour, right? Very good. On to number 3. One day in Boston, Massachusetts, the high temperature was 60 degrees Fahrenheit and the low temperature was 52 degrees. Write one or more inequalities to describe the temperatures T that are between the high and low temperatures on that day. Okay, so we know that the high was 60 degrees Fahrenheit. So T must be less than 60 degrees Fahrenheit, right? But we also know that the low was 52, which means that T has to be greater than 52 degrees Fahrenheit. So there's our 2 inequalities. Our temperature for the day was greater than 52 degrees, but our temperature was also less than 60 degrees. Okay? Oh, but does it ever equal 60 degrees? Yes, because the high temperature was 60 degrees. So I could also say that T was equal to 60, Could I say that the temperature was equal to 52? Yes, because the low temperature was 52. So T could also equal 52. Wow, we have 4 inequalities for this one. Okay, now let's show all of these on a number line. Nice long number line. Now we really only need to show between 52 and 60, don't we? So let's just go, how about, we'll go down here at 48. We'll count by twos. 50, 52, 54, 56, 58, 60, 62, 64, 66. I think that covers everything we need. Now, T can equal 52, so that means I have a solid dot at 52. It was the low temperature, so that is true. But it's also greater than 52, so we know our arrow is going to go to the right for greater than, but I'm going to stop there because I also have another limit, don't I? T has to be less than 60, but it can also be equal to 60. So I'm going to have another solid or closed circle at 60 degrees Celsius or degrees Fahrenheit, but now I have to be less than that. So here's where my two graphs combine. Okay, so again, it can be greater than 52, but less than 60, but it can be equal to both of those ends. Okay, so there's our graph. Very, very good. Last one on this page is number 4, and it actually continues on to the next page, so we'll have to not forget that. It says select all the true statements. Okay. -5 is less than the absolute value of -5. Now we have to remember to solve that first. Remember, absolute value means the distance away from 0. So -5 is how far away from 0? Well, it's 5 units away from 0. So this is 5. Is -5 less than 5? Yes, it is. So that is a true statement. Same thing here. We have to solve this inequality first. What is the distance that -6 is from 0? Well, it is 6 units from 0. Is 6 less than -5? Nope. 6 is not less than -5, so that's a big fat no. Okay, moving on to the rest of number 4 here. Part C, the absolute value of -6, we just discovered is 6. Is 6 less than 3? Is 6 less than 3? No, so that's out. How about this one? 4 is less than the absolute value of -7. Is 4 less than the absolute value of -7? Well, how far from 0 is -7? Well, it's 7 units away, isn't it? Is 4 less than 7? Yes. So D is a yes. How about E? The absolute value of -7, well, that's going to be a +7. Is that less than the absolute value of -8? Well, the absolute value of -8 is 8. Is 7 less than 8? Yes, indeed it is. So our answers are A, D, and E. Okay? Moving on to number 5 now. Match each equation to its solution. Oh, now I want to notice some things before I dive into a whole bunch of math. I have an exponent on each and every one of these. I've got x squared, x cubed, x to the 4th, and x to the 5th. So it looks like it's getting progressively bigger on our exponents. Okay, and then we have a bunch of answers here. And then we have 2, 3, 4, and 10. Let's see if we can do any of these in our heads and see if we can knock some of these out right from the beginning. And the first thing I noticed is x squared equals 100. That's one I have memorized. What times itself equals 100? 10 times 10. Does that make sense? So because 10 times 10 equals 100, that's what matches up with point B. Part B. Okay, now we got some tougher ones here. Let's start with 2. Let's go to the cubed. 2 times 2 times 2. Would that equal 64? 2 times 2 times 2 is 4 times 2 is 8. Nope, that's only 8. So let's go one more step. 2 to the 4th 2 to the 4th. That would be 8 times 2 is 16, not 81. Dang, well, how about 2 to the 8th? Or 2 to the 5th? If I add one more 2, 2 times 2 is 4, times 2 is 8, times 2 is 16, times 2 is, look at that, 32. So D must be 1. Now we've used that one. Knocking these out of the park. Very good. Now let's try 3. I'm going to go to the smallest one first and try it. 3 times 3 times 3. 3 times 3 is 9. 9 times 3 is 27, not 64. So it must not be this one, which means it must be this one. Let's try it out. If I times 27 times 3, does that equal 81? 27 times 3 is 21. 6, 7, 8 is 81. Yes, it is. So 2 must be part A. Very good, very good, very good. Now let's try this one. This better be 4. 4 times 4 times 4. 4 times 4 is 16. 16 times 4, let's try it out. 16 times 4. 6 times 4 is 24. That's 4, 5, 64 is correct. So 3 goes right there. How did you do? Did you get all those right? Hope so. Woo woo! Last one, number 6. The price of a cell phone is usually $250. Elena's mom buys one of these cell phones for $150. She got a great deal. What percentage of the usual price did she pay? Okay, well, she paid $150 out of the total of $250. You see how I turned that into a fraction? She paid, the part that she paid was $150, and the total that she should have paid was $250. So that's a division problem, isn't it? 150 divided by 250. So let's do that math. We know that it won't go in even once, so I'm going to have to add a 0. 250 into 1,500. Well, I know that 250 will go into 1,000 4 times, and then into 500 2 more times, so I think that's 6. And I'm going to try it out here just to be sure. 250 times 6, 6 times 0, 6 times 5 is 30. 6 times 2 is 12, 13, 14, 15, 1,500. Look at that. So that is exactly 1,500. So the answer is 0.6. Now we need that as a percentage. What is 0.6 as a percent? Well, we times it by 100, so we move the decimal twice, and that is 60%. What a great sale. He only had to pay 60% of the original price. Okay? Elena's dad buys another type of cell phone that usually sells for $250. He pays 75% of the usual price. Okay? So not as good of a deal, but still pretty dang good. How much did he pay? Now for this one, we have to think of it a little bit differently, because this time we know the percent. 75% of the original price of $250 would equal the price he paid, but we don't know how much he paid, right? So let's translate this into math. 75% would be 0.75. Of is times, and then 250 equals question mark or just a variable, and I'll call it X. Okay? So now what we have to do is this math. See how different it became? Now I have to do 250 times 0.75. 5 times 0, of course, is 0. 5 times 5 is 25. Carry the 2. 2 times 5 is 10, 11, 12. Holder. 7 times 0 is 0. 7 times 5 is 35. 7 times 2 is 14, 15, 16, 17. Now, because this is a 0, I really don't need to do that spot, so I'm ready to add 0, 5, 7, 8, 1. And there goes my dog. How many decimal places did I have? I have 2, and that's all I had. So 1, 2. He spent $187.50. So that's my answer to part B. $187.50. That's a great deal. Not quite as good of a deal as this one at $150, but I would take that. That's a great price. Okay, that is our homework problems for today. I hope you did well. If you had to fix any mistakes, that is totally okay because that's how we learn. Now you are ready to take the Check Your Understanding quiz for lesson number 9. And I know that, as always,
do your best because you deserve your best.